So this is kind of based on, I would say almost 2 to 3 years now, we've been actually working on trying to figure out how to integrate foundational model into software engineering, okay? So this is work done myself, but actually there's a lot of people here today, you know, or actually not right now with us, but you know, they've actually contributed to that because what we've been working on is trying to rethink a whole kind of Eclipse / GitHub for this type of software, right? So what would that Eclipse look like? What would that GitHub look like? What are the kind of different tools that are needed? What are the kind of big challenges around there? So that's kind of what the talk will be about. And then as well, I'm going to briefly touch on some of the international efforts around foundational models and AI and software engineering very briefly. So a very good example, so I mentioned, you know, earlier today, I said, you know, we have CodeWare and we had AIware. And I said in AIware, there's actually no longer any code. It's somehow just a model doing everything. So, but I didn't really give a concrete example. So a very concrete example is the windshield wipers that you have. So these automatic, you know, rain sensing windshield wipers. So traditionally, this type of, you know, feature in your car will require a lot of additional hardware actually installed to, you know, figure out what's kind of, you know, happening on the windshield, if there's like rain droplets, and then after that, there's a lot of code that people would write, and then based on that code, they would say, okay, yeah, there's water on the windshield, then we'll start wiping, right? So this is the kind of the CodeWare view of the world. Okay? A lot of code there. You know, there's a bug, you need to go change code. Heck, you might even need to, another piece of hardware is missing. For example, okay? In AIware, instead what you have is you put a windshield, you take a camera, and you take 100 pictures of the windshield with rain on it, 100 pictures with the windshield with no rain on it, okay? And then now what's happening is your car, every second or every millisecond is taking a picture, okay? And I've trained now a model, and that model, if I show the picture, it will say, oh, that windshield has rain on it, therefore the windshield system will say, okay, let's start the wiper. So I'm taking a picture, putting it for the model, then the model says, yes, there's rain, and then based on that, it will actually activate the windshield wiper. Okay. So let's say now I am driving and the sun is kind of facing my windshield. The windshield model does not have that type of data. It gets confused and it decides, hey, there is rain. Then that's a bug, right? Traditionally now you pull up the source code and you start editing, but actually you no longer have to do that. All you need to do is you take a couple of pictures with windshield with sun facing it, you know, and then you say that is not rain, and you're done. Yeah. So a very different way of how you would write code. Now this is not kind of science fiction. This is, for example, like Tesla does that. Okay. So the Tesla windshield wiper automatic system, just like the rain sensing automated system does that. Okay. So that's kind of like the differences. So there's no longer code anymore. Now think of that in many other aspects as well of how you can automate software. Now why this is something very unique. The reason this is really unique and special is, unfortunately, as humans, we're not that smart. Even if you think you're smart, you're not that smart, okay? Okay? So if you can think here of, this is the most complex code in the world that we could write, okay? Unfortunately, we as humans, even the smartest of us, are limited by here, right? For example, you know, at least I don't know anybody that could, you know, debug code that say 8 or 20 lines of if statements deep. Yeah. So that's kind of tells you, you know. So here would be a, you know, this would be a code with like 500 if statements deep. Okay. Nobody wants to write that code. Nobody wants to debug that code. So then we're limited by how we can do, which is this here. So when we're trying to write a program, we're limited to kind of that programs that fit in our capacities as humans, right? Okay. If we change this now and we start thinking of this AIware, where instead of writing the code, I give the AI, you know, as I'm building the model, I just give it the parameters. So that's the search space. So I say, you know, this is the search I'm looking for. You know, this is what I'm looking for. And now search here anywhere. You can have the most complex code in the world. And if that code satisfies what I want, then that code is good. Okay? So we have now changed it from me writing if statements to saying, this is my inputs, this is my desired outputs, go crazy, do that. That code now might have 50 level deep if statements. I don't care, because the next time I actually need to fix that code, I'm not gonna fix the code. I'm just gonna add new requirements, new examples, inputs, outputs, right? So a very big change in how we actually do software development, if you think about it. Okay. Now today, a lot of people are concerned, because they think foundational models are gonna take over everybody and we're all gonna lose our job. For us, the folks in the AIware community, we believe this is actually the best time to be in software engineering. When when the calculator was created, we didn't fire all the math professors, okay? When Excel was created, not all accountants actually lost their job. Okay? Instead, what happened is, whether you're a math professor, whether you're an accountant, you started doing more exciting, more interesting stuff, and then you enabled other people to do the basic stuff, right? Okay? So we call these software makers, okay? So now instead of, right now today, there is probably around, say, 29 million developers in the world, okay? And there's 8 billion people in the world, right? If we can get 1 billion of them to be able to do a lot of the coding that they want in an automated way, we can actually focus on the more interesting stuff, right? So going from millions of software developers to billions of software makers, the idea of this happy developers where you're not really focusing on the really annoying stuff, figuring a bug in a 5-level deep if statements, okay? So foundational models enable these more complex AIware, much more closer interaction between the software maker, the end users, and the software, okay? But there is actually a great amount of engineering, a great amount of software engineering to be done. This is not like, okay, everybody take your foundational model and magic can happen, right? And that's kind of what Dai was trying to explain today, right? Yes, they are very powerful, but it's not like magic, okay? There's a lot of engineering that needs to be done around them, the laws of quality assurance that need to be done around them. So we've already kind of talked about the slide before, right? So this codeware, neuroware, promptware, agentware, mindware, right? And then just kind of emphasizing all of this is AIware, okay? And this particular part here is FMware. So in this part here, you're using foundational models, okay? Now the other thing that really we want to highlight is it's not A or B, right? It's not either you're a foundation model dude or an AIware dude or dudette, or you're a code person, right? There actually will be a lot of interaction between these two software systems, right? So you will have promptware, okay? You will have as well the traditional code, so software 1.0, you'll have the neuroware, okay? And all of these are kind of orchestrated with agentware. So it's not the end of the classical software engineering, but it's a whole new rethinking of software engineering on this side, and then how these two interact. How classic code interacts, classic code here, right? Code interacts with AI code where there's no really code at all, okay? And so that's the thing, right? So, and then knowledge becomes a very important thing. Okay? Data becomes a very important aspect in that. Okay? So what you will see moving forward is, even if you have GPT-20, okay? Or GPT-50, right? You will not use that all the time, right? You will mix and match based on many other challenges you have, right? Based on performance requirements, so example, the latency, the cost requirements. So all of this you need to mix and match together. So it really becomes software engineering or building software, it becomes actually a lot more complex, right? But at the same time, we can make it a lot simpler for, say, 80%, 90% of the world. So that's kind of where we see how things going, right? So there's composition of many generations of software and foundational models. Okay. Today, if you think of the complexity of software, so we go from, I would say, end user programming. So when you talk to ChatGPT, I call that like you're doing essay programming. Okay, so you're writing your email, you're programming now your email, right? You're telling, okay, I want to spice up that paragraph a little bit more, tone that one a bit more, okay? Person avatar programming, okay, so you have a helper that's doing stuff for you. Artistic programming, which is one of the biggest things. Today, if you So if you have prompted a model, textual, and you thought you had control of it, just try to prompt it a graphics model, but you actually try to output a picture. You're really gonna cry somewhere in the middle because these models are extremely hard to get them to do stuff for you. You'll be so close, and then you say, oh, can you maybe make the text bold? And then the new thing is a totally different picture. And you're just crying because you can't even go back, okay? So, so this is a challenge here, right, okay? Then after that, we move to what we call enterprise programming, okay? So, so here is the end user is involved, right? But the domain expert and the tech expert is less involved, right? Where in this case here, the end user is involved. There's no really domain expert or tech expert. You are the domain expert. You're the tech, the tech expert. Here, there is a bit of involvement, right? We are now kind of here. So, when you think of things like, Power Automate, Microsoft Flow, these kind of things are in that area. The thing that's not there yet is system programming. Can we actually build an operating system? Can we build a database using this type of foundational models, right? So that's kind of still the open challenge. But we already have a lot of examples of this being done quite well. Okay? All of this still was the user kind of in the loop working with you. Okay? So the way we think about this today, so this FMware lifecycle, so there is a full I think 20-page paper on this that talks about kind of how we see it. So whether from the requirement engineering, we have this new thing which is different from your classical software architecture. We call it the cognitive architecture. So you really need to think deeper about who's going to be doing the thinking here. What kind of foundational models you're going to be using, whether you're going to use one or multiple agents, how the agents are going to start doing the thinking together. So we call that cognitive architecture planning. Then after that, as part of that, how you interact, how the system interacts with the user, the human, is another thing that kind of comes in. And then model engineering, which is some of the stuff, So Dai kind of talked about all of this briefly here and there. This gives you kind of like a high-level picture of how all of them kind of connect together. Then there's the prompt design itself. So that's the kind of the designing the architecture itself, okay? Then there's the, the promptware, agentware kind of being combined. Then there's the traditional software, okay? And now, when we did this work, the idea is you're still going to use the classical way of building this, but we believe as well there is some changes that need to be done for this when you put it into these bigger systems. Then you have the testing, and then the serving and operations. So all of these need to kind of be revisited, okay? One of the things that we have recognized, so the team has shipped a few of these systems, right? Very similar to kind of Andrea Carpacci kind of mentioned, right? So it's really easy to demo a self-driving car going around the block, but making it into a product takes a decade. That's one of actually the biggest problems today with this foundational models type of work is it's so cool to get a really cool demo, but now most leaders say, well, if you can get a demo in 2 months, or maybe like a weekend, therefore, you could ship by next week. That part is really, really hard. It's way harder than traditional software. Okay, LinkedIn had a post on this. So they were saying, we were able to very quickly, to get 80% of the basic experience. But now, as we want to get to the 95 experience, every 1% was extremely painful. Okay. Even in Microsoft, so there was a paper where they interviewed all the people that are working on the copilots, and it's very expensive to test these systems, right? So every test, you really have to use a foundational model. There's actually a real cost happening in there, And Red Hat was saying, in many ways, Red Hat is saying, we finally got people to figure out how to, develop database apps and all that kind of stuff. And then now these type of people now need to build this type of stuff, It's really complex. It's even more complex than the classical newerware. So it's becoming very, very complex. And later in the week, there's a whole kind of session that's going to talk about how you take it from a cool demo to a product. Okay. So this is very high level. Here is, there are a couple of challenges. First is they are not so good at doing complex tasks. Okay. So a lot of times, and we almost call that like a God prompt. So the problem is you can ask GPT to do many things to you in a single prompt, And the idea is because then you'll get all the results quicker, but then if you ask it so many things, it will actually might skip some of the things you asked it for, right? So it said, how do you do that architecture design? And this is kind of the example of this, what we call them cognitive architectures, right? I'm better off asking that question, waiting to the answer, than ask this another one, okay? They hallucinate. So closed loop limitation, they can't use tools outside of themselves, right? You know, now, from an engineering point of pain points, low productivity is a big issue, okay? So if you did prompting, you understand that prompting is just black magic, right? So you're just trying, and finally it works, and you're happy. But then next day, somebody tries a new thing on it, or you put it in production and nothing works, okay? There's a lot of high risks, and there's quite a bit of cost involved, okay? So what we did is we went through all of this and tried to document all the challenges the way we see them, okay? Where we say, okay, these are problems. This is kind of the state of practice, and these are innovation paths. So if people want to do research in this, we think there's a lot of kind of good work that could be done in this space. So that's, you know, what we did for this paper here, and I'm going to go through them. I'm not kind of probably going to go through all of them, just not to bore you, so you can read through the paper. But that just gives you a hint of, you know, here's good ideas that you can pick up and go through. This is based on experiences of shipping some FMwares and developing, as I said, like the GitHub for that type of software, okay? So, you know, one of the challenges here is we are moving from developing code to really about data and curating data. Okay, so it's data programming if you think of it this way, right? So, you know, how do you curate that data? It's much more slower, much more costly to curate that data. Okay, how the data leakage is a big problem today. So a lot of the effort on like code generation has a lot of issues around you know, data leakages. Okay. And how you identify how much is enough data. So one of the challenges today in how people are building models is bigger is better. So more data, more parameters. And as I mentioned earlier, we don't think of them as large language models, we think of them as foundational models. So large is not the big thing, right? You need to figure out how much data you really need to do this. Okay? So state of practice, so, you know, there's a lot of work. So, you know, helping with debugging. So for example, if you find a bug in your model, it's not doing something right, okay? Well, that bug is because a piece of data that went in early on. When you have the whole internet data in there, how do you figure out that one bug, that bad data, you know, or that amount of bad data, okay? So there's work, you know, done by Snorkel on that, right? There's this idea of self-instructing the models, okay? You know, innovation paths, I say. So there's a lot of effort that needs to figure out how to actually make this whole labeling more automated. Okay, you know, what exactly is open source and inner sourcing in this world, right? Now, what is the definition of the license of the data now? It's not the license of the code, it's the license of the data. Okay. Oh, okay, right here. Okay. Now, crafting effective prompts. So, you know, Dai touched on this a bit, right? Prompts are very low level and very fragile. So very small changes in a prompt will change things quite a bit. And I'll show you an example of that, okay? Prompts are not transferable. So you finally get the prompt good for GPT 3.5. You move it to 4, it doesn't work. Actually, even worse, the latest advice now from OpenAI is do not actually do much prompt engineering for the O1 model because it totally gets confused, okay? So, you know, much of what you have, so it's very different in the old world because when we upgraded a component in software, we had assumptions that everything would work out, you know. If you didn't break it, you know, if you didn't touch it, why would it break it? Here it's guaranteed, there's a very high chance it's gonna break, okay? You know, as I said, hard to debug. Prompt debugging is a big challenge. Dai mentioned there's some work that him and a few folks have been working on is actually creating debuggers for prompting. So that's just, you know, classical software engineering. How do you debug prompting? Okay, that's a very important problem to be done, right? You know, so state of practice, there's a lot of work on trying to figure out the inference transparency, okay? How do you map every token that's in the prompt to figure how impactful that token was in the final output? How sensitive was the token? So the work I was saying, the work that was done by Dai and other folks is they would show you like a heat map and it would say, you know, this word here that you never even thought about it, this is the word that the model gets so excited about. And that's probably why the model is giving you weird stuff. Or even worse, the model picked up something that's so irrelevant for you and is giving you the right results, you really should be more concerned even here, okay? Okay, yeah, and then how do you optimize prompting? So how do you make sure that, you write a very simple prompt and you search for it? The best way I describe prompting is if we go all the way back to the beginning where, people went from assembly, like when we're doing assembly. In my opinion, prompting is the same level as assembly, okay? And when we were doing assembly, every 2 weeks or back then the world was not moving this fast, okay? So every 6 months, some person will say, oh, you know what, guys, I have a good way of how to lay out the data and how we can allocate the registers, okay? And then people say, yeah, that's really cool, we're gonna do that, okay? And then 6 months later, oh, no, I have a different way to do it, okay? And then people go change their code. And then people say, this is not working, we need to get a compiler. And the compiler dudes can figure out what's happening here. We just write something at a higher level, and then that gets translated. And then if there's a new paper about a better way to allocate, what do you call them, registers or so on, it just happens magically because I recompile. Okay? We're not at that stage, right? So innovation paths, so I said the transparency of prompting, so debuggability of prompts, higher level of prompting, right? Reproducible prompting is a very big challenge moving forward here. As I said, going beyond prompt hacking to what we call intent programming. So I want to show an example to tell you how sensitive prompting is, because people don't realize. So this is moving from, so this is the first prompt, okay, and this shows you, the task accuracy, right? So the task accuracy was very low. So this was the prompt, so the passage and the answer, okay? So this is the thing, okay? And now you can see it went from 0.036 all the way down to 0.8. And the changes, there is really no changes, okay? So so example, the difference between this one and this one is they removed the colons, okay? Okay? The difference between this one and this, and sorry, they make it all caps. Here now they made it all caps and put the colons back, okay? Here they have the colons, and then so on, right? And here they put it on the same line. They didn't put an enter, okay? So that is an example of black magic, okay? If you never know how it looks like, so that's black magic, okay? So, it's probably, I don't know, most of us got into software engineering and writing code not to do that, okay? So, and I hope, I don't know, I'll be retiring sooner than most of you, and I hope, I hope your life is not gonna be doing that stuff, okay? Shaking the reordering, adding an extra space here, and suddenly your software is much better and you can go home for the weekend, okay? The other thing is multi-generational software. Yeah. So it's multi-generational software is, as we said, so there's codeware, neuroware, promptware, agentware, all of this combined, right? How you integrate them together, you change the software. One of these software is how you make sure, evolving it in all general, okay? So state of practice, today we know that a lot of the models have this idea of plugins or tools to help them work together, okay? How you package the legacy code in there, okay? Recognizing the key thing here is, which is a big problem that people need to realize, it is not the separation of all the code we have worked in the past will be thrown away and everything will become foundational model powered FMware. That's one. Second, even 5-10 years from now, there will still be codeware in specific aspects where it's just good at, and other paths will be FMware. Okay. So how do you make it reusable? The legacy and dealing with only the software and the data itself. Okay. The degree of controllability is another challenge too. Okay. So software in some domains, require much more, robust controllability, but foundational model, AI in itself is inherently stochastic. Okay? There are words which are called like standard operating procedures where you tell the model, this are the steps I require to do, and you actually can verify them to ensure that happens. Okay? Human oversight is being done in there. Okay? Now, the same way when we created, apps, mobile apps, we created some kind of like permission system for models, right? For apps, what is the permission system that we'll have, moving forward? And then the other thing too is you can need to balance between the controllability, how much control you give, and how much autonomy you give to the cognitive AI, right? Because one of the pure powers of this is if you let the AI explore, it will find things that us, a human, might not think. Remember that the circle I showed where it can deal with much more complex way of thinking, right? For example, today we think you design software, you write code, you test code, then you do performance measurements. But we could do all of this together, right? And to be very concrete, actually, so this is another example from Tesla. So Tesla's very early automated car driving system had many AI systems, and what the AI systems were trying to do is they were trying to figure out object identification. So, okay, there's a passenger here, there's a tree, there's a traffic light, and then based on that, they would take all of this, and then they would write some code to figure, based on that, should the car go right, left, stop? Okay. But the thing is, they said, well, actually, we really don't care about anything. What we really care is, should we go or stop? Turn right, turn left, stop. So why don't we build a model, and the model's final answer is just go or not go, turn right or turn left. So how we reach that decision is not the core thing, it's really actually got the right decision. So we've separated, we've given the cognitive model a lot more exploration. So if you try to dig in there, it might be so complex how it decided to do that. But at the end of the day, that's not what the developer wants to be concerned about. Instead, they're just concerned about the inputs and the outputs, and then the final solution that satisfies their need. Okay? Compliance and regulations. So, there's a lot of government regulations happening here, moving forward, right? Now, here's the part where I'm gonna go very fast, okay? Unless you guys are not gonna have lunch, okay? So, GDPR, the AI acts are kicking. I think, in the next 6 months, there's a lot of EU AI acts that are gonna be enacted, and technology-wise, nobody's ready for them, okay? License compliance of data itself, of the open source models that are being used, okay? Now, state of practice today, there's a lot of manual work here, okay? For me, this is probably one of the most important areas moving forward because, well, first, it's gonna be a lot of money because there's a lot of lawyers in there, okay? And second, just very limited automation, very limited deep understanding of what's happening in there, okay? So this idea of an SBOM, bought for FMware, is an interesting point, okay? How do you do testing and formal verifications of regulations and license compliance in this setting? Okay, and then how do you do privacy preserving, operations for all the data you're sharing? Okay. For example, as you can see, like Apple AI, Apple AI has tried to do some of that. Okay, they have created their own architectures to do that, but there's much more can be done in there. And later in the week, we're going to talk about some of that. Okay. So collaborations, the best way I describe it today is, we are at the state of, the Stone Age, the punch card era of how to collaborate. We have went from, you have your your VI, then we went to this okay, Emacs, then to GitHub, right? So you went from a text editor to an IDE to actually a whole platform for development. Okay? But right now we're really at the text editor part. People are copying and pasting between text notepads. Okay, not the best way, right? How to package, how to distribute it, treat them. I'm gonna get it. Okay. So there's a whole paper on this. I'm just here to highlight the main stuff. Observability is one of the most challenging things that we have seen today. Is how do you debug it? Okay. So the easy answer you just put, so we used to make fun of people and say, yeah, you don't have really debugging, you put printfs in the code, right? But the problem is there's no code. So even the guys that were hacking it are messed up, okay? So how do you actually debug this? How do you debug the reasoning of an agent? Later in the week, we're going to talk about some of the work that's being done in this area. But primarily today, a lot of people are just doing like telemetry. Oh, this is number of calls, this is what's happened. But nobody can answer the question, why did the agent do this? Now, the question is, well, it's very simple. We could just ask them. The problem when you ask them, this, similar to in physics, an observer effect, they might change their answer. So even if you ask GPT any question, tell me why you did this. Oh, sorry, thank you for noticing this. I did a mistake. So that won't work. So a lot of work to be done. Performance engineering, so in the last day we're going to have a whole session that talks about performance engineering, but the biggest way to talk about it is today is doing an inference in a model is expensive, okay? Then the other challenge is, well, if you create these very elegant, complex cognitive architectures, so it's like a thinking architectures, right? The latency becomes very high. So you can get a powerful model that can give you an inference immediately, or you can give a model and give you similar power, but you combine multiple models and you have a complex architecture where people are reasoning and debating, but then the latency becomes higher that you cannot really use it. Okay? Testing under non-determinism is another problem, so I'm going to kind of run through this. Siloed tooling, so we talked about a little bit on that. So there's no unified platform today that has that cradle-to-grave life cycle support and extensibility. So FM Arts, so this is the platform that a few of the folks at Huawei have been working on, is basically develop a whole infrastructure to develop that type of software, okay? So at the bottom, it actually has its own compiler and its own runtime, okay? So that does a lot of performance optimization. Then there are special frameworks to let people write to that type of software. So different, like frameworks to write prompts, frameworks to write agents, frameworks to write workflows. And then at the top, how do you manage all these assets? And then different studios to help you with different type of capabilities. And then marketplaces. Around 3 weeks ago, this went live. So it's actually accessible in the whole world at this moment. Unfortunately, it's still in Chinese. Okay, but I think you'll have an English one sometime soon. Okay, but it's a whole end-to-end kind of processes, and there's a lot of innovations happening in there. Okay, so that all I can say is this is just the start, right? Tackling these challenges require technology breakthroughs, standards, and community efforts. So there's a paper here. There's a couple of pointers for our other efforts done in there. Now I promise as well I'm going to briefly run for some of the initiatives done not just by the AIware people, but other people around. Okay. Now, first is there's the CREATE SE4AI program that's kind of working more on teaching people how to do some of this work. Okay. This originally was started before foundational models, but now it's kind of expanding to foundational models. There's the work by the OPEA initiative, which has basically brought a lot of companies around the world for that same thing, is how do we build enterprise AI type of software. There's all the initiatives coming out from the big community of the AIware community, okay? We just held this conference in July this year. This is actually, at that time, we decided to run this tutorial. Well, originally it was going to be a tutorial, but now it's a whole bootcamp, okay? Okay, and the next edition will be at ASC in Korea, okay? There's other efforts that are focusing only on the code, so LLM for code, okay? So there's a workshop happening in Ottawa at ICSI early next year. Okay, so Liming Zhang and a lot of the folks there are working on this efforts. OPEA, we're gonna have the head of the OPEA Technical Steering Committee will be talking later today to kind of give you a glimpse of what's happening. But all these companies are realizing today there's a big gap between academia and what academia knows and industry and industry's needs, and how do you actually build that software, how we can have the worlds kind of work together and across industries and across universities. Okay. SPDX, so the Linux Foundation has just released SPDX 3.0. In there's something called AIBOM, so it's a bomb, so a software bomb if you have software, if you have AI. But now, what is the software bomb if you have an FMware? So some of the work that's being done on that, Gopi's led the SPDX 3.0, and he's actually working as well SPDX 3.1. So if you have any interests in there, come talk to him. He's looking for a lot of smart people to help on this. It's a very big challenge today. Okay. The Linux Foundation, the LFAI and data has actually started about this model openness. So today, everybody says we're open source. What is open source in this new world? So the Linux Foundation is trying to understand that. Okay, as always, MSR, my dear friends. Okay, so where's Bram? Bram is somewhere here. There he is. Okay. So so Bram and a few, and Olga, right? Yes. Okay. So general chair and program chair for MSR are here as well. So MSR is really, a lot of this has started, we've been looking into AI systems for, 22 years, okay, at least. And trying to figure out how that fits with software engineering is some of the very interesting questions that we need to ask. And in April, next year, it's going to be someone work on that. Okay, so that's everything I have. So thank you.
Thank you for the talk. Do we have any questions? Maybe we have time for like a couple questions.
Yeah, there's one here.
Where? Sorry.
Thank you. So my question is more like integrating FMs into the system, because when I compare FMs, I see them as a services that became popular in early 2000. And they said, okay, let's start service programming, service-oriented programming. So different services and a central program that managed them. And still, they cause a lot of problems because of the health check. What if they're not available? What if the authentication fails? And a lot of things that developers don't like service-oriented programming a lot, unless it's necessary. So if we have a very good FM, it works completely good. What do you think of the future of, I'd say, FM-oriented programming, which has FM manager, like package manager? We have FMs. They have APIs. They work together as an agent and create an output. The system has the database. The system has transactions. It's a complete system. What do you think of the future of these systems?
Yeah, when we started, so we're not hardcore systems people, but we actually recognize as we started looking into that, how do you put these things together, and using service-oriented kind of programming, it just won't work. If you treat all of them as just a service and you're actually serving, 5, so if you have 5 inferences, that means you have 5 separate services being delivered. That won't work from a scalability, from everything. So the Fusion runtime, right? I don't think there's not a lot of papers written on this yet at this moment. Mm-hmm. Okay, but there's going to be a talk at the end of the week that talks more about some of the vision that team has been working on. Mm-hmm. Is really trying to figure out how to go beyond just 10 inferences, because you're really serving an app, And even today, so for the longest time, people thought, well, the trick is in training, and inference is simple. But with the O1, they showed that no, the really big progress can be happening by creating more cognitive complex architectures and serving these cognitive architectures, right? And if something, for example, like something like O1 and needs to do like 5 inferences, and it cannot move to the next step unless it does all these 5 inferences to get it to decide to move to the next step, and you're just doing a service-oriented platform at the bottom, the schedules and the priorities won't happen, right? So then there was going to be a lot of issues. So you need to think of serving FMware, not serving inferences. Mm-hmm. So that's moving forward, and then you have the whole package management and all these things moving forward, So
how soon do you think this is going to be commercial?
Well, so the runtime is commercial, right? Well, it's for free at this moment, right? Anybody can use it for free, right? How long before we get that? Well, so the Huawei team has started thinking about that, 2-3 years ago. Berkeley has started thinking about what they call compound. So compound AI systems is actually FMware. Okay, it's the same thing. So Silicon Valley is picking up now. So I expect 2 years. Okay,
Thank you.
Is there a question here?
So we all know the researching the larger language model are really expensive. So like OpenAI spend $100,000 to develop various feature. So their works much faster than our independent developer. So my question is when we try to start a business as an individual developer or small team, So which direction should we focus on or avoid that?
So we have a whole career panel, later in the week. Yeah. So the point right now is, so they call that the moat, right? So what's limiting us today, for example, for a lot of young people is, or even small companies, you don't have access to a lot of compute, right?
Yeah.
So I think if you look at O1, and a lot of the excitement behind it is that it's showing that you don't really need a lot of compute. With smart designs and re-architecting, you can do a lot of good work. There's something called as well the phi models from Microsoft. So the phi models are very small. So the small models is really where the power is going to be coming. So I think at the beginning, it was all about big, right? We're now getting where, no, it's not about big. It's actually about how do you design things right? How do you size them right? Okay. So I see there's a lot of initiatives in there. So I feel if you want to do research in training large language models, you really need to be very close to industry. But beyond that, I think there's a lot of interesting work that can be done in there.
But there's an example. Like I know someone built a PDF reader, and later the GPT
Just add it in there.
introduced the PDF in the GPT.
Yes, yeah.
Yeah, and there's a problem.
Yeah, so I think Y Combinator, so one of the biggest VC capitalists in the Valley, has this annual meeting. And I think one of the guys, we came out and said, if I hear another person doing a ragware on top of an FM, I'm going to kill myself, right? So the problem is if you want to innovate, what's happening today is just putting a model and just putting a rag on top of it is not sufficient to really get extended, right? And a lot of people say every year, I think it's May was telling me, right? Every time GPT has a new version, X number of companies go out of business, right? So, but this has always been the case. The question here is you need to find something that's unique. I think today, when it comes to how to build these things efficiently, how to serve them efficiently, we're not there yet. Usually the things work is more about, okay, initiative, getting people excited, so this is where we are. But now quality, costs, all that kind of stuff is where I think there's going to be where people are going to be excelling, okay? If you put enough people in a room to build an operating, like a software system, you can do it. So that's a lot of money. But whether this is the efficient way, the speed way of doing it, that's where a lot of companies today are actually competing, is on the speed, the quality, the cost.
Thank you.
Okay.
Maybe the last question, okay. There we go.
Thank you. It's in the current landscape of foundation model, if prompting is assembly of our time, what might the compiler of our time looks like?
What would be the compiler for FMware, you mean?
Yeah, yes.
Yeah. So later today, I'm going to be talking about the next generation compiler.
Okay.
Yes, yeah.
Thanks.
Okay, good. That was perfect.
Okay, if it was perfect, then I guess let's clap for Ahmed. Thank you for the great presentation. And then, we're going to have lunch, and I expect you to be back in an hour. Thank you. Thanks, everybody.
We come back at 1:40.